Good evening all. Welcome to ACE Engineering Academy and ACE online platform, ACE Online. Guys, it is privilege to introduce myself, K. Hanumantha Rao, having nearly 20 years teaching experience. Out of that, 15 years I'm mentoring for various aspirants, those who are preparing for GATE, ESE and PSUs, public sector units. Here, ACE Online. Now I am here to interact with you for lecturers in Government Polytechnic in Technical Education Service under TSPSC. This is the general recruitment was given. And guys, for this session, I am going to take for electrical and electronics engineering for network theory subject or network subject. Guys, you know that under the notification of TSPSC for Polytechnic examination, for Polytechnic lecturers examination, first I would like to give that what is the scheme of the examination and what is the syllabus for electrical, electronics and communication engineering, and what are the subjects or what are the syllabus under electronics and telecommunication engineering for Polytechnic lecturers post examination. And also I would like to give that for networks, what are the expected questions or expected areas we are going to discuss. And one more thing guys, today we are having only 1 hour session. That's why I would like to take one important topic under networks. I will give the brief introduction for that one, and also I would like to solve some examples under that topic, and also some common questions, entire syllabus I would like to discuss. Okay. Now I would like to start with that, what is the scheme of the examination, after that syllabus, after that the networks and important topics we are going to discuss. Let me start with that here. For electronics and communication engineering once you see that, this is the scheme of the examination here. As you know that the scheme of the examination, whatever we have discussed under electrical engineering, the same scheme of the examination. General studies and general ability is 150 questions, 150 marks, and technical is 150 questions, but 2 marks each one. That's why we are getting 300 marks. Totally 450 marks we are getting, right? And you know that general studies and general ability bilingual, nothing but the in Telugu as well as English you will get it. While coming to that concerned subject, technical subject, you will have only English, right? And these are the concerned subjects we are considering under this post, whatever the Polytechnic lecturer post you are going to attempt for this examination. These are the branches, various branches they are going to be conducted under these branches, the post, right? And while coming to that here, this is the syllabus. The syllabus here, the syllabus for electrical, electronics and communication engineering. In this, you know that as you know the scheme of the examination, paper 1 and paper 2. In the paper 1, non-technical is there. Under non-technical here, general studies and general ability is there, right? While coming to that here technical version, in this one we are having nearly 4 or 5 sections. The section 1 is also non-technical, which includes that engineering mathematics under degree level. Under engineering mathematics, linear algebra, the major topic, complex variables, probability and statistics, numerical methods. These are the main topics we are having under the syllabus of here mathematics. While coming to that section 2, this is the technical version, section 2, section 3, section 4. While coming to that section 2, networks and electronic devices, analog circuits, amplifiers. And while coming to that section 3, digital circuits, combinational circuits, sequential circuits, microprocessors, linear time variant systems, control systems, and tools and techniques for LTI control systems analysis. Nothing but under control system we are having. While coming to that section 4, communication side, communication, analog communication and digital communication, and under section 4 you are having electromagnetics, right? But this, if you see that networks and electromagnetics under electrical engineering was there. Now, I am here, I am the faculty under electrical engineering with the subject networks, right? That's why first I would like to consider that what is the syllabus here. This is the syllabus under instrumentation engineering also. Both are having the common syllabus. That's why the network subject commonly we are going to discuss. Now, this is the electronics and instrumentation. The instrumentation students also eligible to write this examination under this syllabus, okay? And my subject, if we take that fundamentals, we are having that networks. And this is the syllabus under instrumentation engineering, right? This is the major part which I am going to discuss, which I am going to interact with you, right? While taking that networks, see this, the syllabus under network solution methods, nodal analysis and mesh analysis, network theorems. Under network theorems, already we have discussed here, and star delta transformation technique, steady state AC circuit analysis, and time domain analysis. This is what I can say that this is under transient circuit analysis by using the Laplace, and frequency domain analysis with RLC circuit, and linear two-port network parameters. And this is very important here. Today I am going to lead with this driving point and transfer functions. This topic usually, so many students, you may have some doubts under this topic. Today I will provide that the detailed solution regarding the driving point and transfer functions. State equations for the network, this is, you may get it under where in control systems you will get the control system subject, driving point and transfer functions. This topic will be under network functions. This topic will be under network functions. Guys, first I would like to give that the detailed theory under network functions. This topic, driving point and transfer functions. This is very important here. Driving point and transfer functions. Majorly driving point questions, you may expect nearly 2 questions minimum you will get it. And people are thinking that, those who are attempting for electronics students, they are thinking that this topic is somewhat difficult. But once you see that today topic, if you concentrate more under today's topic, definitely you will comfortable more, right? See the network functions here. Let me start with that network functions. See this one. The network functions, first of all, how you define the network. We have a one-port network, two-port network, multi-port network. In one-port network here, we are having that, how many parameters here I can take it. The parameters we are having that with this, variables are depending upon that. Only voltage and current variables. While coming to the two-port network here, 4 variables are there here. 4 variables are there. In this one, 2 variables, which are what? Voltage, current. In this one, 4 variables. In this one, multiple. Multiple means what? Suppose if you want to take this one as a here, this is 1 dash V1, I1. This is V2, 2 dash. This is V2, I2. Like that here, V3, nothing but what? 3 dash. Like that, this I can take it for n times. For n times I can take it. Right? For n and dash, this is Vn. This is the n-port network here. Now, how many variables for this one? 4 variables are there. How many variables in the one port? 2 variables are there. Based on the number of variables are defining for that network, we can define the number of parameters for this. For this one, you know that for 2-port network, you are aware of that 4C2. If n is the number of variables, then I can say that the number of parameters can be defined is nC2, 4C2, here 2C2, nothing but what? It is 1. Are you getting? It is 1. And this is what? 6 type of, already we have discussed. Now let me take that for Network functions, how you take for the network functions. Already we have seen that network functions for one port as well as two port. For one port, you know that the type of the function which we can take a driving point function, because only one port, either driving point impedance, driving point admittance. These are the two types of the functions we can take it, impedance, admittance only, right? But nature of that parameter is what, only one type of parameter, that is what, driving point, either impedance or admittance. While coming to this two port network, you know that Z parameters, Y parameters, so many types of the parameters, driving point function, transfer function, everything we will discuss, right? Everything are existing into this one. Now under these network functions, if you want to discuss about that, here network functions for one port network, according to the syllabus, we have questions. The previous examinations, if you see the questions are under one port network here, under one port network. Now in this one port network, we have type of the, here Z is V by I, this is the driving point impedance, getting, and the Y is inverse of this one, I by V, this is the driving point admittance. Are you getting? Right. Now here Y is equal to 1 by Z, you can take it. This we can take it here, not a problem for this one. You can take it directly this one. Right. Now while coming to this one, usually this topic you will get the synthesis. Under network synthesis, we are going to take it for one port network. The questions are asking from the previous examinations, if you see that, this is under network synthesis. Guys, first of all, what is the basic difference between synthesis and analysis? Let me define that, synthesis and analysis. This is analysis. Under analysis, you know that input, under analysis, you know that input, nothing but voltage and current. If you take that load, this is the load part here. Whatever we are considering that load part, here, this is the input. See this, and this is the network, and this is the output. And remember this, guys, I can say that this is known, input known, network known, and output is only unknown. Whatever the analysis we are doing under networks, everything is related with this. Input is known, excitation. Network is known, he has provided the network, whatever the elements are present. And we need to estimate that output, nothing but load response across, or output power across the load by using the network techniques, which are, what are the techniques? Network theorems, nodal analysis, mesh analysis. Under various techniques, by using that, we are able to estimate that output power. Now, while coming to that here, this one, network synthesis. Network synthesis means this is the input and this is the output. Input and output. Are you getting? And this is the network. This is the network. Let me consider that here. This part, this is known. Are you getting, guys? And this is also known, and this is unknown. How we need to realize the network? We need to synthesize that network. This is the unknown. What type of network? Or that network is made with what type of elements? These are the questions you may expect under network synthesis. Synthesis means we know input and output. How you know that input and output? Usually he will provide the network function. It may be either transfer function or driving point function. Usually one port network, you have only that, we have only the driving point impedance or admittance functions. While coming to the two port network, we have the transfer functions also, and gains also, current gain, voltage gain. These are all we are having under two-port network, but one-port network we have only driving point functions. Using the driving point, either impedance or admittance, how to realize the network, how to design the network, how to synthesize the network by knowing that input and output. Analysis means already what we have done under the first 4 chapters, that is nothing but the analysis. Input is known and network is known, output we have to be estimated, right? Now while coming to this one, whatever we have taken that here, this part here now we are going to take it, and this part we will consider that this is for two-port network here. You just make a glance on this one, driving point transfer function we have the for two-port network. We are not going to be discussed according for two-port network, because this is not under syllabus. Under synthesis we have the syllabus only under one-port network, right? Only one-port network. Let me consider that here. The one-port network, Z of s is equal to 1 by y of s, but two-port network, Z12 is not equal to 1 by y12. Why? Because Z and y parameters, since the conditions are different. Why conditions are different? Are you getting, guys? Why the conditions are different? The conditions are different. Z parameters are open circuit parameters. Y parameters are what parameters? Short circuit parameters. That's why conditions are different. The functions will become Z and Y parameters under the conditions of open circuit or short circuit. That's why under two port these two are not equal, right? Now while coming to this one port, it is possible, right? One port it is possible, because we are not considering any conditions under one port network. Now let me consider that here, how you realize the network, how you synthesize the network. If you want to synthesize the network here, using the pole zero configuration, I would like to estimate that, or I would like to synthesize, I would like to design, I would like to synthesize, I would like to design, I would like to realize the network. What are the elements are present in that network? Now let me define that first a network function, which is h of s. It can be anything, driving point impedance or driving point admittance. This is called network function. Usually network function we can define like this, the numerator function and denominator function, and that we can express in pole zero notation. This is the pole zero notation here. If we take common here, whatever we have considered this part, this is the scale factor, I can take it k. Then under that instant, s minus z1, s minus z2, so on s minus zn by s minus p1, s minus p2, so on s minus pn. Here z1, z2, z3, so on zn are zeros of h of s. Getting? p1, p2, p3 are pn are poles of h of s. Are you getting? Now if you are able to write a driving point function or whatever the function, I can realize that network here. How you realize the network? If you want to realize the network, suppose if you take that one port network, which is nothing but what? Driving point network, driving point impedance or driving point admittance function. Now how you take that network? How you take the network? Let me consider that here. The first part, whatever you have taken that, any function, if you want to consider that network function, that should be a positive real function, which is having a stable function. You know that poles and zero positions or poles and zero poles positions for system stable, left half of the S-plane, you know that. This is the stability region, this is the unstable region, left half, right half. Now our functions, whatever we are considering, that left half of the S-plane or on the imaginary axis. Now let me consider that these are the conditions for, necessary conditions for driving point functions for pole zero locations on the S-plane for a positive real function, right? Now let me take the here. This is the main part which we are going to discuss under one port network here. This is the starting of driving point synthesis. Now the driving point synthesis of one port network with two types of the elements. See this one. Evaluation of the elements of the network from its driving point impedance or admittance, that is the impedance. Combination of admittance or impedance is called impedance. function is known as a driving point synthesis. The synthesis of driving point impedance is nothing but it is either impedance or admittance. It may be either Z or Y. Three types of the networks we can realize here according to the conditions. First RL, whatever you have taken that, RL network, RC network, LC network. And also one more you can all take it, RLC network here, RLC network. That one also you can take it. Now let me discuss one by one. First for RL network, nothing but if the network is having only elements R and L, how the location of poles and zeros for a driving point impedance function, like that for RC network, how the location of poles and zeros, right, on S plane, like that LC, like that RLC network. Let me take that one by one. RL network, see this one. Right, properties of RL driving point impedance function here. This is valid only for the impedance function here. Now, poles and zeros lies on the negative real axis for the stability, and the residual of the poles must be real and positive, and this is very important here. The critical frequency of frequency nearest to the origin or at the origin must be 0, where as the critical frequency nearest to infinity or at the infinity is pole automatically. Now let me define or let me explain by using a simple example for this one. Can I take that? Shall we go for with the example how the network, suppose if you consider that driving point impedance function is related with RL driving point or RL elements. Let me consider the simple example for this one. See this, Z of S is equal to S plus 1 into S plus 3 by S plus 2, S plus 4. Now tell me here, what are the poles for this one? The poles I can take it here, S is equal to minus 2, minus 4. What are the zeros? By making this you are getting equal to 0, zeros you are getting minus 3. Now let me define that here, how the poles and zeros location on S plane. Once you consider the zeros we are having, this is minus 1 and this is what I can take it minus 3 and this is minus 2 and this is minus 4. Which is nearest to origin? See this one. The nearer to origin or nearest to origin is what? This one I can take it as 0. Nearer to origin is 0 or at the origin also. Sometimes you may get that at the origin, right? Sometimes you may get that at the origin. That example also I can take it like this here. Suppose Z of S is equal to, what I can take it, S plus 2 into S plus 4, S plus 4 by S into S plus 1. I can also take like this, right? Here S into S plus 2. This is pole and alternate. S into S plus 2 by, here zeros are there. 0 is nearer to origin. Then another time I can take it here. 0 is nearer to origin means then definitely we will take it S into S plus 2 by S plus 1 into S plus 3. Tell me here, what are the zeros for this one? Zeros are S is equal to 0 comma minus 2. Poles are S is equal to minus 1 minus 3. According to this, what I can take it here? This is, I can consider that the poles and zeros, this is 0, next pole, next 0. Poles and zeros are alternate and what we are getting? Minus 1, minus 2, minus 3. This is what I can take it, right? Pole as a origin, 0 as origin. 0 is origin. We can also take like that. This is the function which is related with what? RL driving point impedance function. RL driving point impedance function. What is that? Just guys remember here, for RL driving point impedance function here, poles and zeros are alternate and they lies on the negative real axis, and nearer to origin is 0 or at the origin 0 should be there. This is about that RL driving point impedance function. Like that RC. RC means what? Just you remember. Reverse. Nothing but what? Poles and zeros are alternate and they lies on negative real axis and nearest to origin is pole. Very simple. Or at the origin is pole. That is for what? For RC driving point impedance function. Poles and zeros are negative real axis which are alternate, and the critical frequency nearest to origin, see this one. Critical frequency nearest to origin is what? Must be a pole or at the origin. Now let me take the example for this one. Are you getting? Example for this one is what? I can take it here. Example, poles are, the poles here, tell me, -1, -3. Zeros are -2, -4. I can take it here. First one is pole, next one is 0, next one is pole, next one is 0. Here nearer to origin is what? Pole. No? That's why here this is pole nearer to origin. According to that, I can take it. Is it right? Based on that, we will consider that for RC driving point impedance function. And once you see that, see the before one and this one. Before one is what? See this. This is s plus 1 into s plus 3 by s plus 2 into s plus 4, and this one, see this. Reverse, na? That's why driving point impedance function is equal to 1 by driving point impedance function. That's why I have taken like that. Right? 1 by z of s is equal to 1 by y of s. Now, RL impedance function is equal to RC admittance function, you will get it that. RC admittance function, you will get it. This statement is also very important. That I will provide. Now, let me take the third part, which is for LC. LC is what? Properties of LC driving point impedance function. Poles and zeros of the impedance on j omega axis, that poles and zeros are alternate, and here we are considering that they must be either 0 or pole at the origin, we can take it that, and or infinity. These are the points we have to consider that. Take the example, right? You can see this one. These are the properties here. Because we have less time, that's why I am showing this. You can read it, not a problem. Everything is. But I will spend the time at the example, definitely. Now, let me consider that poles are what? Here poles s is equal to 0 and plus or minus j root 2, and zeros, what are having zeros? S is equal to plus or minus j minus plus or minus j root 3. Guys, indicate this, whatever the poles and zeros, we are considering that poles are existing here and here and here and here and here. Right, here. Only 3 poles are there. 0 plus j root 2 minus j root 2. And zeros. Suppose if you consider that zeros, where the zeros we are having that 0, this one is 0 and this one is 0 and this one is 0 and this one is 0. Now what we are having that plus j and plus j root 3 minus j root 3. Yes or no? Minus j root 3. Is it right? Minus j root 3. Is it right? Now, poles and zeros are alternate and they lies on the imaginary axis. They lies on the imaginary axis. This is about that LC driving point impedance function. Right. Now, let me consider that. Suppose if the function is like this for RLC. See this one. Properties of RLC driving point impedance. Poles and zeros are impedance or admittance function are complex and conjugate pairs and they are symmetric about the negative real axis. In the above cases, see this one, this point is very important. Instead of impedance function is given, if the admittance function is given, then they are converted into impedance functions first, and then above tests are to be performed. Then the above tests are to be performed. Suppose admittance function is given. These are all properties whatever we have discussed. These are related with what? Driving point impedance function here. But suppose in the examination, if is given that driving point admittance function is given, what we need to do that? First you should be converted in terms of driving point impedance. Then you have to perform the above test results. Whatever that above tests or whatever that RL, RC or LC properties are there, those properties you need to be checked. Then according to that I can say that the network is made with either RL or RC or LC or RLC. I can define the network, I can synthesize like that. Network made with what type of elements, right? Now let me take this. This is about the simple explanation or fast explanation or network functions under driving point impedance or driving point synthesis. This is the total part which we are getting. These are the points you need to be remembered under network functions in the exam point of view. Guys, let me consider how the questions in the examinations. How the questions in the examination, definitely you will answer the questions. You will answer the questions now? Yes or no? Yes. We will take that. Have you got that? The three conditions, whatever you have taken. LC, RL, first RL here, this one. Next RC, this one. Next LC, this one. Next RLC. This is very important topic here. Let me consider this here. RL impedance function is equal to RC admittance function and vice versa. Immittance is nothing but, guys, you may get a doubt here. Meeku oka doubt vastudandi. What about the impedance? Immittance. Immittance is nothing but what? Either impedance or admittance. While he is giving that immittance, he will provide that function f of s. Suppose if given f of s is equal to s plus 1 into s plus 3 by s plus 2 into s plus 4 given, then what we need to do? We should consider, this is impedance. Suppose if we take that impedance function z of s, it will coming to the what? 0 is nearer to origin. Z of s is RL impedance function. Now suppose y of s, you are considering that. This is what? RC admittance function. Both are same. If it is given f of s, we can define either impedance function or admittance function. Are you getting this? Right. This is the overall view under network functions with the driving point synthesis. Guys, let me start with that examples. Now see the examples from the previous examinations. Okay. First question. The lowest and highest critical frequencies of RC driving point impedance are respectively. The lowest and highest RC driving point impedance here. See this one, RC driving point impedance function. Tell me that which is the correct option for RC driving point impedance function. Which is the correct option? For RC driving point impedance function, which is the correct option? Tell me that. For RC. RC means what? Pole is nearer to origin. First, lowest and highest. Lowest is what? It is pole. Lowest is the pole. And highest is what? Highest is 0. With this, what I can take it? A pole and a 0. Where it is? A pole and a 0. Which is the correct option? Option B is the correct one. Option B is the correct one. Is it right? Now let me take the next example. Is it clear? Okay. See that a network immittance is immittance. Just now we have discussed with the impedances. Na? Yes or no? Impedance we have discussed. Impedance means what? It can be either impedance or admittance. That's why he was given f of s. Now according to this, what we need to do? First we should take that what? We should consider that pole zero diagram. According to the pole zero diagram, I can take it now? Yes. As per the pole zero diagram, I can consider that first. Tell me here. S plus 2 into S plus 4 by S plus 1 into S plus 3. What I can take it? First one is what? Nearer to origin is pole, no? Right. Nearer to origin is pole. This is minus 1. Next 0 minus 2. Next minus 3. Next minus 4. Is it right? Nearer to origin is what? Nearer to origin is pole. Pole is nearer to origin. That's why what I can take it? It is RC impedance function. But here f of s given. This we can take it RC impedance also given. But it can be RC admittance also. Both A and B. Both A and B option is given. Yes, RC impedance or RL admittance. That's why we should consider that C is the correct option. Suppose if it is given, if this is not given, both are not given here, both are not given here, we can take it either A or either B. He will not give like that. Either RC impedance function or RL admittance function. It is not RL admittance function. RL admittance function can be. This is also correct. But actually, whatever the exact answer, it can be either RC impedance or RL admittance. RL admittance. This can be, this might be impedance function. This is correct. This is correct. Both are correct. Both are correct is given in the C option. That's why if that option is provided, we should go for that one only. Right? This is not given, then either A or either C. It can be either multiple select questions. But here given, that's why C is the correct option. Is it right? Is it okay? Right. Next one. See this. The question is, the pole zero configuration of an impedance function is given as shown in figure, then the network is. See that. As per the pole zero diagram, I need to be take it. Now tell me this, which is the correct option? Right. As per that, which is nearer to? Pole is nearer to, na? This is the pole. Pole is nearer to that. Pole is nearer to origin. Same, whatever we have discussed. Pole is nearer to origin means what? RC realizable. RC realizable. We can take it. It may be either impedance or impedance function is given. Impedance function means compulsory RC only. You may get it out, sir. Why can't you take out RL? But he was given only impedance function here. According to the pole zero diagram, impedance function is given. If pole is nearer to origin, then definitely we should go for what? We should go for what? RC impedance function only. RC impedance function only. Right. Check the next one. Which of the following is correct for driving point impedance function? Right, again impedance function is given here. Tell me this. This is related with what? For RC, Z of S is given. Z of S is given means you go for that first poles and zeros. First take this one, S square plus 1 into S square plus 3 by S into S plus 2. Is it right? This is S cube, I think. S square plus 2. S cube plus 2S. Now from this, I will consider that what are the poles? Poles and zeros will be, I will take it. Poles are S is equal to 0 plus or minus j root 2. It's the same whatever we have taken, zeros. This is what? Plus or minus j1 plus or minus j root 3 here. This is what? LC na? LC network na? Just now we have taken that. Under exercise or under theory part, we have discussed this. We have discussed this under theory part. LC network, because poles and zeros are alternate and they lies only imaginary axis. That's why this is network for driving point impedance function is related with what? Only L and C. C elements are present in the network. Okay. See the next one. Reciprocal of a network function here. Reciprocal of network function. You know that reciprocal of network function means what? See this one. Impedance function is reciprocal if the original function is the impedance function. Impedance function. Okay. That is either impedance or impedance. Transfer function. Transfer function reciprocal is not here. Never a transfer function. Never an impedance function. Impedance function never means here. But here I can take it reciprocal of Z of S. F of S is the solution for this one, I can take it. F of S can be either Z of S or Y of S. Nothing but. Suppose impedance function is given. That reciprocal is also called impedance function. That's why this is V of S by I of S is equal to I of S by V of S. Both are immitance functions. Getting guys? Both are immitance function. Are you getting? Both are impedance function. That's why impedance function can be either 1 by reciprocal, right? But transfer function you will not get it here. Transfer function you cannot take. Transfer function means usually as per the definition, output by input is usually referred as a transfer function, right? Usually referred as a transfer function. That's why impedance function can be considered as reciprocal of that one. Reciprocal of network function is same as the original function. Impedance function can be either impedance or admittance, but we cannot take the transfer function. Transfer function means what? Either V2 by V1, I2 by I1. These are not equal here. But this can be referred as either impedance or admittance. Reverse. Right? Next one. See that these are the some of the examples which I can take it under network functions. These are the examples which you can take it network function. Now guys, for ECE, the previous examination questions and expected questions also I have provided. Let me consider that one by one. See this? Tell me that. Observe the given figure. Find the Thevenin's equivalent resistance seen from the open circuit terminals. Very good here. Open circuit terminals. What is that open circuit terminals? So we need to take it. We should consider that R equivalent here. How you consider that R equivalent? By making that this one is for R equivalent, this we need to consider that open circuit. Na? For R equivalent, take that current source is open circuit. Yes or no? Now under that instant I can take it. These two are in parallel. Yes or no? These two are in. Can you tell me that? These two are in parallel. 20 and 60, 80 by 16 you are getting. Na? 16 and 16 series. This is how much you are getting that? 16 ohms you will get it now because 20 into 80 by 100. 16 you will get. 16 and 16 both are in series. Then R equivalent is equal to 16 plus 16 which is 32. You need not go for any calculation partner. Yes or no? Right, option B is the correct one. For ECE simple questions you will get it here. Believe me. See the next one. What will be the value of current in amperes through the 6 ohms resistor for the given circuit diagram? Tell me this. This is a very simple question. Tell me this here. How you take this? Current we need to estimate for this one. How you are getting that current in this one? If you want to get the current for this one, definitely here 16 and 4 are connected in parallel, total in series with 2. Now, first you have to find out that resultant current. By knowing the resultant current, you can take it. I value, this is I 6 ohms. Now, R equivalent value how much? This will take some time for solution. 16 in parallel with 4 plus 2. What we are getting that 16 into 4 by 20 here, 5. Nothing but what 3.2 plus 2. Nothing but 5.2 here we are getting that. Now total current how we are getting that? 40 by 5.2. Here 7.8 or something you are getting that. Now once you will get the total current, I can take I6 is equal to. I6 is equal to what? Here. I6 value how much? I6 value we are getting the total current I into opposite resistor 4 by 4 plus 16, 20 na? That's why 7.8 into 4 by what I am getting that here 20. Now this is 5 times here 1 point, what we are getting that 1.54, 1.5. 1 means right 1.56 like that or 54 we are getting that. According to this 5.6 we are getting. That's why option C is the correct one. Very simple here. Are you getting this? First estimate the total resistance. Get the total current. Then use the CDR. Here what we have used by CDR, current division rule. From this current division rule I can get it here. Yes or no? Is it right? See the next one. Right. Now the question is, determine the conductance in moles of a conductor when the value of current that flows through a conductor is 2 amperes and the potential difference between the ends of the conductor is 40 volts. Conductance means what? It is the inverse of resistance here. It's a very simple here. Conductance means G. It is inverse of R, which is equal to I by V. I is given how much? 2. 40 given. Now 1 by 20, 0.05 mhos. Option B is the correct one. Need not go for any calculation, but I am giving that clear total explanation for that one. Is it right? Simple. These type of questions you may get it. These are the previous questions here. Right. This is the good one here. The voltage V and current I of a device or V is equal to 100 AC circuit analysis here. This question is under AC circuit analysis. Now the voltage V and the current I of the device or V equal to 100 sin 370 70. I is equal to 10 sin 370 70 plus 30 degrees. Plus 30 means what? It is leading or whatever it is, our power indicated by the wattmeter. Wattmeter reads what power? Active power. Active power means what? P is equal to VI cos phi. Yes or no? VI cos phi means what? V. 100 by root 2 because this is RMS here. This is what value? Maximum value. We should convert in terms of RMS. This is RMS value. Remember that. This is what value? RMS into 10 by root 2 into cos 30 degrees. Now cos 30 is what? Detailed explanation here. You need not go for calculation part directly also we can take it. Without pen also we can do it, but I am providing that once this session is completed, if you see this video, you should get it clear picture of each and every solution. For that purpose, I am taking this one, right? Now this is 5 times and this is 50 times and this is 250 into root 3. Now 250 into 1.732. Now 250 into 1.5 times is what? You know that 250 into 1.5 means what? 3 by 2 no? Nothing but what? 750 by 2. Actually 1.5 more than that we are getting that. 750 by 2 means what? What we are getting 750 by 2? It's a 774 no? This one is maximum value root 3 by 2 cos 30. How much you are getting that? 100 by root 2. Here 10 by root 2, 250 root 3, 250 root 3. 500 less than 500, nothing but only the D option is there. That's why D is the correct one. 433 watts we are getting. Like that also without calculator you can take it. Guys, you may get a doubt. Here sir, calculator is required now. No need. According to the option you can select. 250 into 2 is 500. Less than that 433. Only one option is given. That's why you can take it. Is it clear? Yes or no? Yes. Now, next one. See this one. Good example. The current I is equal to 10 plus 10 sin t amperes is passed through a moving iron type meter. The reading is MI. MI means what? Moving iron. Moving iron reads what? Definitely moving iron reads RMS value. Now the RMS value is equal to, moving coil means it will take the DC. Moving iron means RMS value. RMS value means what? With this I can take it under root 10 square plus 10 by root 2 whole square. Yes or no? Now what we are getting that? 10 square means 100. 10 by root 2 whole square means 50. Under root 150 amperes. Is it there? Yes. Option C is the correct one. Is it right? Is it clear? Option C is the correct one. Now let me take the next example. Series resonant circuit implies. This is the direct definition here. Very simple definition, you can take it. Zero power factor and maximum current. Unity power factor and maximum current. Unity power factor and minimum current. Zero power factor and minimum current. You know that series resonant. Resonant means what? Resonance means, you know that it is UPF with Imax, Zmin, Z minimum, which is R. Series resonant. Unity power factor and maximum current. Very simple. Yes or no? Now let me take that, the next example. Right. The current read by ammeter A in the AC circuit shown in the following figure. Tell me that. Tell me guys, what we can take it. Ammeter readings given for RLC parallel circuit I is equal to under root. This is the observation here. IR square plus IC minus IL whole square. IC minus IL whole square. What we are getting that? It is 1 square plus 5 minus 3 whole square. What we are getting that? 1 plus 4 under root 5. Right. R square is equal to 3 here. This is very important here. You may get some confusion regarding this one. You may get some confusion regarding this one. Where the resistor, this resistor is given middle. And this is inductor and this is, we may take like that. Yes or no? That's why what I have to take it here, 3 square plus 5 minus 1 whole square here. This is 5 amperes. First I have taken, this is R, this is L, this is C. But middle is the R. You should consider like that. You need to be identify where the resistor current was given. That is important. Now option B is the correct one. Option B is the correct one. Got it this? This is a very simple. Simple questions you may get it here. You need not think about deeply regarding the network questions especially. Right. See this one. A geyser is operated from 230 volts, 50 cycles per second means the frequency of instantaneous power consumed by the geyser is. Right here. Power here, instantaneous power. You know that instantaneous power means double frequency, 2 omega. If this is omega, 2 omega. Nothing but what? 2 into 50. How much that? 100 cycles per second. Option C. Very simple. Why you are getting like this? Geyser means what? It is the coil. Coil means it is the inductive load. For inductive load, instantaneous power, the power equation, if you see that, instantaneous power P of t is equal to, you will get the final expression like this here, Vi cos phi, one is the independent of frequency, Vi sin 2 omega t minus phi, you will get it. When this V of t is equal to supply frequency or supply frequency is equal to omega. Now from this I can take it here, the supply frequency is equal to omega, instantaneous power frequency is what? 2 omega, we are getting that. That's why I can take it here, suppose 50, this will be 100. Are you getting? This you remember this. This is the expression you should remember. This is the expression you should remember, right? Let me take the next example. What will be the value of current in amperes drawn from 4 volts battery when wire of 20 ohms resistance is stretched to double its original length and then cut into 2 equal parts, and these equal parts are connected in parallel? Very good here. Suppose, this is very simple here. Without taking calculations, I can say that. First, I will explain like that. Then after that, I will take the detailed explanation. First, what it is, a wire of 20 ohms. 20 ohms wire, it was structured to double. Length is double here. Once you stretch that length is doubled, then area of the cross section will be half. Na? Then at the time, total resistance value of the structured conductor will be 4 times. Na? Because n square times of R, I have given that. Na? Because here L1 value is equal to 2L, A2 value is equal to A1 by 2. Then on the time rho L by A, na? 4 times you are getting. Na? 4 times of 20 is what? 80. That 80 is cutted into 2 pieces. Those 2 pieces are connected in parallel. Nothing but each piece is what? 40. 40 and 40 are connected in parallel. How much the resultant? 20 ohms. Is it right? The 20 ohms you are getting that are equivalent and 4 volts battery. 4 by 20 is the current passing through that. 4 by 20 is what? 1 by 5. 1 by 5 means 0.2. Option C is the correct one. This is the way how you can take it. And the same example which was given in ECE examination here. Latest, recent ECE examination, it was given that a conductor which is having 36 ohms structured, 36 ohms bend into equilateral triangle and across one side, what is the resultant resistance? First I will take this one, then we will go for the next one, that example. Now this one is what? 20 ohms, this one. After that, what we are getting that this is the length L and he made that 2L by stretching. Then area of the cross section is equal to this one. Here area of the cross section A2 is equal to A1 by 2. Here we are getting that. This is L2. Then definitely what we are getting that R2 is equal to what it is? 4 into 20, which is equal to 80 ohms. This cut into 2 portions, then he was connected across these 2 resistances, 40 and 40 ohms, across 4 ohms battery. What is the resultant current? I is equal to 4 by 40 parallel with 40, 20, 1 by 5, 0.2 ohms. Is it right? This is the way. And recent question, it was given that 36 ohms, which was, this is totally 36 ohms resistance of conductor. This is bent into equilateral, nothing but what? Here 12 ohms, 12 ohms, 12 ohms. Now what I can take it this one, if you take 12 ohms, across this by looking into these 2 terminals, R equivalent is equal to what I can take it, 12 plus 12 parallel with 12. How much you are getting that? 24 into 12 by 36, which is equal to 8 ohms. Right? This is also, this example was given in the latest ECE examination, TSPSC, under TSPSC. Okay. Next one. See that, determine the heat dissipated in joules through a conductor of 10 ohm resistor, and when 1 ampere is passing through that, 5 seconds. It's very simple. What is that? W is equal to I square R into T. Very simple. 1 square into R. 10 into 5 seconds. It is 50 joules. Option A is the correct one. Sir, no. Very simple. Next. Which one of the following statement is true about the Kirchhoff current law? The sum of currents entering at a node is greater than the sum of the currents in the leaving at the node. It is not correct. The sum of the currents entering at the node is smaller than that. It is not correct. The sum of the currents entering at a node is equal to sum of the currents leaving. Sum of the currents entering at the node twice of this one is not correct. It's very simple. By reading this, it will take 1 minute. That's why you should be careful regarding that each and everything you have to read. This is the sample question I am taking that. some questions you may get it under test series. That's why those who want to attempt that TSPSC Polytechnic examinations, then definitely you should go for that more number of tests. Test series, online test series or offline test series you should attempt, right? Now, let me take the next one. Norton's current in the circuit shown below. Norton's current means what? Short circuit path current, na? Yes or no? Once you make short circuit, your current value how much? Current is equal to 0. Here current is equal to 0. Here how much current? 12, right? 3 into 12, 36 by 3, which is equal to what? 360 by 30, which is equal to what? I can take it 12 amperes. This is the short circuit path current. IN value, Norton's equivalent current. Yes or no? Norton's equivalent current. Form factor and peak factor here. What is the form factor into peak factor? Form factor is equal to form factor into peak factor. This is very simple here. Now form factor means what? It is RMS by our average. This is what? Peak value, maximum value by RMS value. Now this RMS will be cancelled now. What value you are getting that? Maximum by average. Where it is maximum by average? Option D. It's a very simple here. Yes or no? Getting? Right. An electric heater is connected across 230 volts and it draws 2 amperes. Then the resistance, it is very simple. R is equal to V by I. 115. D is the correct option. You may get a doubt here. Inductance value, less inductance. We need to neglect that one under heater. More resistance is there. Because suppose if you take that, with what we are taking that heaters, heaters are made with what? Nichrome material, right? More resistance, right? Less inductance. Okay, these are the questions, right, which we can expect in the Polytechnic examinations, guys. And today's session we are going to complete it, right? Whatever the questions or whatever the concept. Today I have discussed that network functions or network synthesis. Definitely you will get 1 or 2 questions on this, compulsory. You concentrate this. Those who are not having the confidence on network synthesis, you please watch the video. Definitely you will get that concept and 100% you will get the marks in the final examination. Okay? Thank you all of you. All the best.